This is my presentation on bonding covalent molecules. A covalent bond is the bonding of two or more nonmetal elements that share similar electrons in order to follow the rules of both octet and duet. For the rule of octet, we know that the noble gases have 8 valence electrons, meaning that they are stable. Other non-noble gas elements bond with each other in order to try to simulate this feeling of stability. For the rule of duet, this rule is specifically for the elements hydrogen and helium. This states that both elements must have no more than 2 electrons in their valence shells. So now that we've gone over why nonmetal elements bond, here is an example, HNC. This covalent bond is composed of 3 elements: hydrogen, which we know has the valence number of 1, nitrogen, which has the valence number of 5, and carbon, which has the valence number of 4. Because we know each of these valence numbers from the periodic table, we can predict how they will bond. Step 1 in predicting is writing down each element's Lewis dot diagram. For nitrogen, we see that there are 3 available bonding sites. For hydrogen, because it only follows the duet rule, there's only 1 bonding site. But for carbon, because it likes to balance its electrons, we see that there are 4 available bonding sites. Step 2 is finding the number of bonds. The first part of this is adding together the number of electrons. And for hydrogen, we have 1. For nitrogen, we have 5. And for carbon, we have 4, making 10. The next step is dividing by 2. And of course, 10 divided by 2 equals 5. And the last step is subtracting the number of single pairs. And like I said before, there's only 1 element with a single pair, and that's nitrogen. So that would be 5 minus 1, making 4 bonds overall. Step 3 is determining which element goes in the middle. This is always the element with the most open spaces, and from what we talked about before, we know that hydrogen has 1 open space, nitrogen has 3 open spaces, and carbon has 4, meaning that carbon is going to be our central element. Step 4 is time to bond. Since we know that carbon is our central element with 4 open bonding sites, and that nitrogen is in need of 3 electrons, we know that a triple bond will be needed. Now, carbon only needs 1 electron, while a hydrogen also only needs 1, meaning that there will be only a single bond between these 2 elements. Step 5 is naming covalent bonds. But before we get into this, we have to make sure that the rules of both octet and duet are being followed. Because hydrogen follows the rule of duet, we see that there are only 2 electrons. 1, 2, making hydrogen good. Carbon and nitrogen, however, follow the rule of octet. From this, we see that carbon has 1, 2, 3, 4, 5, 6, 7, 8, making carbon good. Nitrogen, by having 1 single pair and 3 bars, also follows the rule of octet, because each bar represents 2 electrons, making it 1, 2, 3, 4, 5, 6, 7, 8, also good. As for naming, some covalent bonds already have common names, while others follow a standard naming convention. This convention has prefixes, as well as endings. Exceptions include that mono should never be used as a prefix for the first element, and that when with oxygen, the prefixes tetra, penta, and hexa lose the letter A. Because my covalent bond, HNC, has the combination NC, we know that it is called cyanide, meaning that my element is called hydrogen cyanide. Thanks for listening.